Welcome everyone to today's Edison Electric Institute webinar, Strengthening Climate Resilience, Preparing for and Responding to Natural Disasters. My name is Vanessa Ferrero and I'm a manager for international programs at EEI. Today's session is part of EEI's Destination 2050 Dialogues, our COP26 webinar series that focuses on critical issues for the clean energy transition. We are excited to welcome three speakers today. Larry Bekkedahl, Senior Vice President of Advanced Energy Delivery at Portland General Electric, Yoshiki Onoi, Executive Vice President and Head of Global Power Business Division at J-Power, and Ian McLeod, former CEO of Ergon Energy. They will be joined by Lawrence Jones, Vice President for International Programs at EEI. This session is a dialogue, so we encourage you to ask questions for our speakers using the chat feature. Lawrence will aim to incorporate as many of them as possible into the conversation. Without further ado, I will turn this over to Lawrence to get started.
Thank you, Vanessa, and good morning, good afternoon, and good evening to everyone. Welcome to our second webinar in the series of COP26, counting down to what is going to happen in Glasgow, but also what is going to happen after Glasgow. Today's session, as Vanessa mentioned, is focusing on a topic that we know is going to be critical for the energy transition going forward and for dealing with climate, which is how do we strengthen climate resilience? How do we prepare for and respond to natural disasters? And I am very glad this morning for you this evening, for me here in Washington to have three dear friends, Larry, Yoshiki, and Ian, from three parts of the world where I think we've definitely have a lot to learn. From the western part of the United States, where Larry is based, from Japan, where Yoshiki is, and Ian McLeod coming from Australia that has its share of multiple weather and have had all kinds of interesting things happening from a weather perspective. So gentlemen, welcome. Let's start, and I'll ask you to unmute your phones or your computer so we can get this conversation going. So Larry, we'll start with you. Can you just tell us a little bit about your company, just for the audience who may not know what PG is?
Sure. Thank you, Lawrence, and good day to all of you. Pleasure to be here and participate in what I think is one of the most important things that we as an industry can do in terms of resiliency and talking about our way forward as we decarbonize. So Portland General Electric is here on the West Coast. If you're familiar with Oregon, I'll just say we're halfway between San Francisco and Seattle, if you're thinking worldwide. And Portland is right here on the coast. We have mountains to the east and the coast to the west. We serve approximately 2 million households, 900,000 meters, but the people that are in the greater port of Portland, Salem area is where we are concentrated. We are electric utility. Roughly our peak went up this summer. We'll talk about that heat spell that we had, the bubble, but we increased the peak by 10% this summer, and we are now a summer peaking utility. In the past, being in the Northwest, we had been a winter peaking utility, but over 4,000 megawatts, 4,400 megawatts was our peak this summer. We have a mixture of thermal and hydro, wind, solar, and then we have a market here in the West Coast, our energy imbalance market, but we have bilateral contracts that we buy and sell from other utilities as to fill in all of our energy needs. So I'll just say we're one of the densest from a forestation or vegetation for tree canopy. And so that creates unique opportunities for us here also to manage the electric system. So I will stop there and turn it over to my counterparts, Lawrence, but glad to be here.
Thanks, Larry. Yoshiki, let's go over to Japan. Tell us about J-Power.
All right. J-Power is a generation and transmission company acting across Japan. So our company, we have, roughly speaking, 18 gigawatts all over Japan. By is 60 hydropower plants, 11 thermal power plants, and 5 megawatt by wind and geothermal. And one nuclear power station is under construction right now. We are waiting new approval upon new safety criteria right now. Also, we have shares of overseas power plants of 7 gigawatt roughly by CCDTs and hydro and offshore wind farm in UK. So Japan has many disasters, as you know. We had a big disaster 2011 Fukushima accident occurred there. Upon such experience, we are very earnest to discuss about resilience of power supply always. I'm very happy to join this discussion today. Thank you.
Thank you, Yoshiki. And finally, Ian, you bring a wealth of experience from across Australia. You are, former executive. You ran Ergon Energy, but now you're touching so many different parts of Australia in terms of what is happening there. So, give us an idea on the work you're doing currently as you sort of expand your scope of activities across the country.
Right. Thanks, Lawrence, and welcome everybody. As said, I formerly ran Ergon Energy between 2007 and 16, and through that process was exposed to a number of disaster events, particularly cyclones and flooding. So that's certainly pricked my passion over the years around how can we manage those events better than we currently do today? How can we introduce data intelligence technologies, etc., the resource assistance type programs that happen in the USA. So Australia is a fairly flat, dry continent. We're exposed to those cyclones. They are getting, certainly the last large one, Yassi, was quite significant. We had the black summer of bushfires that burned the largest proportions of Australia natural forests ever. And that certainly got attention as it got close to our capital cities, etc. Recent events in Victoria where the networks there had unprecedented wind events that took down assets and had people off supply for extended periods of time, never before seen in Victoria. So certainly one of the dimensions I'm trying to bring into this, we talk about the energy transition, there's also the asset transition that goes with it, the infrastructure to be able to deal with those events and also deal with the change in energy. In Australia at the moment, we're having significant low load issues with the highest penetration of rooftop solar in the world. We are turning off solar energy and wind energy and spinning generation to keep security to the grid. So a combination of energy security and infrastructure security and adaptation is certainly what I've been focused on.
Thank you, Ian. So let's jump right into Glasgow because that's where the world is going to be for the next 2 weeks. And the big focus is going to be how do we build resilient energy systems. All of you have talked about the importance of resilience to some extent, but yet and still, most people don't understand what it is. So what are some of the challenges we're having in explaining the value of resilience to policymakers and regulators and others? Why don't we start with you, Larry, and then we go to Ian and then Yoshiki. Any thoughts on that? How do we explain this complex thing called resilience?
I think the last 18 months has been pretty easy as I think about how to explain resiliency. We started out with May of 2020. We had a microburst that blew down 3 miles of 500 kV transmission towers. That seemed to kind of start the summer. In August, or excuse me, Labor Day came and we had wildfires. And the wildfires here were started primarily due to a northerly wind that came into Oregon, we normally see in the winter time. We don't see it in the summertime, but that that northerly wind came through and, really was devastating, blew a lot of trees in to power lines, et cetera. Wildfires were started. Those that were already existing had been lightning strikes, et cetera. We burned up more acreage in the first 3 days of that event than we normally do in an annual year. It just spread, very, very rapid. And so the experience of wildfire, we'll talk about turning off power, et cetera, for customers. We did our first public safety power shutoff in the Mount Hood area, kind of a national park, but it's also quite a few customers that live up there on the mountain. And I'll just say they were very pleased that we shut the power off because their homes were saved. And that was the first time for me to realize that it does make a difference. We need to think about how, and what resiliency means in a wildfire situation. Now I moved to February. Now that was a 1 in 50-year event. I go to February and we had an ice storm here that was 2 inches of ice on conductors, trees, and you can just imagine the devastation associated with that. It was about two weeks solid of outages and trying to rebuild the system. That again was an ice bubble that was right in the Willamette Valley. We hadn't seen that since 1964 to that level. And it was a big surprise to us. It just really the damage associated with it. Then finally, we go to the summertime and we get a heat spell, a bubble that comes in 116 degrees Fahrenheit in Portland, Oregon. Who would think? You've got Phoenix, at 100 and I think it's 20 degrees. You had Las Vegas at 118 degrees as the highest temperatures ever in the United States. And then Portland at 116 degrees. Just unfathomable for a metropolitan area. And so having to live through those, each of those requires something different out of an electric system. And how you survive that, what's the resiliency? And all on top of that is the pandemic. We have people living at home, working from home, teaching their children from home. And, that resiliency means, do I have lights? Do I have my computer systems? Do I have communications? It's really the commodity that we provide is extremely important to the economy today. And I think we have to think differently to make sure that water systems are still operating, that sewer systems are still operating, that people can survive, whether it's heating or cold circumstances. And so resiliency is really trying to think about how you manage a system through all of those types of events. Mother Nature is throwing at us. We've all talked about cybersecurity and how we deal with the bad guys. Now we're having to think about Mother Nature and what is she going to do to us? So let me stop there. But those stories really make and resonate when it comes to resiliency for a community to be able to survive and manage itself through weather conditions.
So Ian, based on what Larry said, is it safe to say now that everyone gets it? That everyone has seen the bushfires in Australia, they've seen the cyclones that you've talked about, they've seen what Larry has talked about, we'll talk to Yoshiki soon. Do you think everyone gets it now? People understand resilience and the importance of resilience?
Look, I think we've hit a bit of a tipping point in Australia, and I think it's, as per usual, it's been driven by events more than anything else. The cyclones in North Queensland or Central Queensland, we get a lot of attention in Canberra, but when you've got bushfires coming down on Canberra and Victoria and Sydney and the Australian Gulf Open covered in smoke, it starts to draw the attention of others. So I can see that in some of the federal government programs that are currently being put out in terms of grant programs around disaster resiliency and drought resiliency. So there is definitely a recognition happening. Whether it's at the right level or not in terms of understanding what can be done, I think there's a bit more to do. To New South Wales' credit, after the bushfires or the Black Summer of bushfires, they are in the process of looking at building a digital twin capability for the whole state. Now that came out of the bushfire inquiry. So it's a combination of spatial and IoT intelligence mapped or connected to all the enterprise intelligence and department intelligence. So yeah, I'm seeing action. I've really seen a tipping point. And I would say that tipping point started with the Black Summer of bushfires. One point I'd like to make in that, in terms of getting people's attention, was we spend a lot of time on climate, which we should, but the Black Summer of bushfires created more emissions in Australia than our whole annual emissions output. So in one event with these bushfires, we created more emissions than Australia's annual emissions.
That's interesting.
And it's that sort of message that sort of says to you, well, you know, typically what we see is 4% is spent on resiliency historically, and that's been well documented. 96% is spent on recovery. And we're going to flip that around a bit. And I guess I'm saying I'm seeing some of that now happen.
Yoshiki, let's move to Japan. You guys have a very interesting evolution of things. You had the big event 2 years ago with the storm that hit. Obviously, you know, everybody remember Fukushima and other things. What is the conversation like today in Japan when it comes to resilience? Are you getting more understanding from the policymakers and from the community about the importance of resilience?
Okay, so in Japan, people are very much aware of resilience, not resilience, power outage, according to disasters. Big one was the Fukushima accident. But we have now some events about our Japan's general election and COP26. Then politicians are talking about new renewable era and putting new renewable energies more and more. But nobody is talking about resilience of power. And people tend to discuss about more solar power and wind farm, offshore wind farm, and batteries. This is a good word for discussing CO2 reduction, but we don't hear honest talk by politicians and people about continuous power supplies. But administration officers of METI and power people of our sector are heavily discussing about the stable supply of power under new era of renewables. So people say more and more wind, more and more solar power, and batteries, chemical batteries. But if we look at our problems of power supply, we have to discuss more about network, enforcement of network, because as you say, non-stable renewables brought some very extraordinary network condition in Kyushu area especially, but we have two issues we should discuss. Network experts should say that proper demarcation between power storage and enforcing transmission lines is very important for two reasons. One is networking of non-stable renewables minimizes the sum of volatilities by respective plants in total, according to law of large number effect. The other is that the more enforcement of network, the more robustness of strong power supply against natural disasters. We are not discussing about network in general, but people, experts are very aware of that. People tend to buy stock of Tesla for battery manufacturing instead of investing in cable manufacturers.
Interesting. Now you make a valid point. Is where is the focus of the investments going? Okay, let's get a little bit specific in terms of some of the events that have occurred and how you responded to it. Larry, let's go back to you. Can you give us a few examples of one or two of the major events and how PGE responded to it, and what were some of the experiences you learned from that event or those events?
We start with kind of the wildfires in the West. And I'm going to say the West, not just for Portland General Electric, because we've had some occurrences where wildfires come through and they disrupt transmission. And in the West, we have generation a long ways away from load centers. And so very key element of the West is the interties between California and the Northwest. We call it the California-Oregon intertie. There's also ties into Canada to the north and to British Columbia. We also have ties that go out to Montana, and generation coming across from all of those avenues to the West Coast for the most part. And so we had an occurrence where we watched the wildfire move towards the 500 kV and eventually was underneath. Didn't damage the 500 kV, but the carbon in the smoke caused the flashover and you lose the transmission. So all of a sudden, California on a hot June day, July, I think it was July 9th, if my memory is correct, has roughly a peak of 43,000 megawatts. They just lost 7,000 megawatts of access to Northwest generation because we lost the not only the AC, but there's a DC line as well. So all of a sudden, California, I'm on the phone call with Elliot Mainzer, who heads up the California ISO, and they're watching as solar is coming off of the system in the evening, but loads are still high because you're not cooling fast enough. And if the solar falls off fast enough and the loads don't fall off, at the same pace, then there's a really good chance they're going to have rolling blackouts. And so they sat there for those moments, just sweating every minute, hoping that they're going to hold the system together. That's one occurrence that led us to think about, from a Western Electric coordinating system across, do we have visibility into wildfires? And is that made aware to all of the operators, the balancing authorities, et cetera? Do they see that? And so it was instituted shortly thereafter, visibility into all of that, so that if there is going to be a wildfire, what are we doing about it? And how can we protect, the transmission along lines that we've got? A little bit later in August, we had a similar circumstance up in Canada. And it took out the 500 and 1,100 megawatts, tripped off. And, we have reserves that across the Northwest, we all pool, and we were able to recover very quickly, but nobody was watching those. And so we had to add that to our equation to say, okay, when those transmission lines go out, we need to do the same. And we have another occurrence that's, looking at it from a Montana perspective as well. So I share that as we have to look and think differently about what does resilience really mean to all of us, and how are we responding when the states don't have funding to either respond to the wildfire when it's moving toward the transmission. Do we collectively do something different as an industry? Should we be thinking about it differently? And so I think those are the challenges that, and to use that as just one example of, trying to harden, trying to be resilient, think ahead of what that disaster might be coming your way.
Interesting you talk about visibility. I'll come back to Yoshiki, but Ian, tell us a little bit about Australia and some of maybe give 2 examples of 2 major events and the kind of response you saw coming from some of the utilities.
Yeah, look, probably the biggest one was Cyclone Yassi, which is a while ago now, but in terms of scale, it was Category 5, which was coming into one of the large regional centres in Queensland. we're obviously mapping it and tracking it as you go. One of the first things you learn is not to rely on those maps and tracks because it continued to sort of oscillate between crossing in Cairns down to Townsville and then eventually went through the middle. It was quite broad, and that event at that time led to the largest deployment of line resources in Australia. So we had pre-staged people coming up from New South Wales and Victoria into central Queensland, had them logistically driving there in their truck, setting them up in accommodation, etc., getting ready for the event to occur. The local councils have their own disaster resilience plans, etc., but often we find sometimes they put too much reliance on the power companies. So I think from memory we deployed nearly 200 odd larger scale generators out to commercial businesses. The water supply for the regional city of Townsville was about 200,000 people. Had lost supply. We had to provide generation for that. So from an industry perspective, I thought the collaboration at that time was good, and I've seen some of that occur in events across Australia at the moment. I would like to see it a bit more in the context of the US, where you've got mutual assistance agreements already in place. I do know in a recent event there's been some debate about the utilisation of resources and the costs across different entities, and that's not really helpful when the events happened. But usually it has been fairly good from that perspective in terms of industry perspective. Getting into a position where industry is as prepared as the utilities for these events, I think, is a big challenge. Because you want to be focused on getting the power up and all those sorts of things and hoping that industry and business has done their bit. You really don't have the resources to be running around trying to do all those other things, but you do, because you want society to get back on its feet. The quicker it can get back operating, the better for everybody. So there's some of the things we've learned with Yoshiki is a large event, cost Ergon at the time $104 million over days, so weeks. So the project management associated with that is massive. The scale of it compared to the US, of course, is significantly less. I remember when Rod West, I got him to come over from the US and talk to the disaster resiliency and planning sort of seminars across Queensland, and I think he said $2 to $3 trillion of assets at risk across the Gulf region. So the business case for doing it a lot better is quite strong.
We will come back to this issue of collaboration, and let me just prime Larry because I want him to talk a little bit about the collaboration we see across the US. But before we do that, let's go to Yoshiki. In Japan, J-Power, you all have had lots of events there. Can you tell us about one or two and how the J-Power respond, or just the industry in Japan alone respond in terms of emergency response to these kinds of events?
Okay, so we have good examples in Japan which would interest you. One is the Fukushima case, and the other was blackout in Hokkaido Island 3 years ago. These are good examples to discuss about today's issue. 10 years ago, no need to explain, Japan experienced Fukushima #1 accident by a big quake of magnitude 9.1 with a 15 meters high tsunami. The return period of that size of earthquake has been calculated every 1,000 years. The plant was not broken by seismicity, but by tsunami. That plant was designed against 5 meters high tsunami. The plant lost all power supply for cooling reactors and caused hydrogen explosions. Then serious processes followed. I'm explaining about Fukushima, but if there is a Tokyo Electric friend listener here, please correct if I say something wrong. Then, however, as for power supply in the period of a pessimistic situation, blackouts have not been directly occurred by that accident, except a few days planned outage in Tokyo and vicinity, because Japan's relatively redundant power network functioned very well. In this case, a continuous power supply should be stopped by immediate safety confirmation process or network just after the accident. But the real seriousness came from Fukushima 1 accident. All of 54 nuclear units in Japan had to stop at once operation and be under stricter safety appraisal process, including units under construction. It still lasts today for 10 years after the event. This is one case. The other, Hokkaido blackout, was occurred by relatively smaller earthquake, not like Fukushima. Sensing an extraordinary vibration of a turbine, 2 units of a large coal power complex stopped automatically. 1 gigawatt were lost. At almost same time, 2 circuits of main transmission lines were damaged by the earthquake. Supply recovery sequence of power units could not be normally achieved due to transmission lines failure. One more unfortunate was due to backup supply from main island through JPA's DC submarine cable or rapid increasing aerial demand. For complexity of many changes of flows on the grid caused frequency control failure. It can be said that multiple troubles in a short time by one disaster can make recovery sequences difficult. Unexpectedly, a committee carefully studied the case and brought mitigative measures, both by improved operation rules and by additional inter-island DC submarine cable plan. After all, these are 2 good examples. What should we do from now on? So both physically and some institutional formulation by private sector and public sector. Maybe the demarcation and the cooperation between private sector and public government, that is very important, I think. Anyway, I talked about 2 events. This is very, yes.
No, that is very good, Yoshiki. And I'm glad you mentioned towards the end of your remark, you talked about private sector and public sector. And this is where I want maybe Larry, can you just say a few words about how important collaboration has been in the West to deal with some of the issues you've had in terms of, whether it's wildfires or some of the other events? How important has collaboration within the industry, but then between the industry and government, how important has it been?
Actually, it's extremely important. And I'll just say, let's start with the industry itself. And we have public utilities, we have private utilities, and even Bonneville Power Administration, which is federal. And having worked in all 3 of those sectors myself, I will just say that the electrons don't care what form of government or what form of money is paying for it. The physics behind it is still the same. And the issues of operating together is extremely important. And we are tied very closely to each other. And so when these events take place, mutual aid, as you were describing, calling upon, and we all know that we may be taking care of our own, And at some point, if we can release and go work with others, we absolutely do. And so across the entire US, we have sent crews to the East Coast or East Coast to West Coast. And very frequently during winter storms, it happens regionally. So maybe just in the Northwest. As I mentioned, the ice storm that was just here, you could go 40 miles north or south and there was zero ice, but it was all centered in one location. So we were able to bring in crews very quickly from outside of the area to come in and help us. That's all coordinated. It is truly through the mutual aid agreements that we all have and the coordination that we have here. I will also call out, a new organization, the International Wildfire Mitigation Risk Consortium. That is made up of California utilities, a few of the utilities here in the Northwest, and then also Australian utilities. And so the whole notion was we need to learn from each other. And we even have a few South American utilities now involved in that. But the focus is wildfire, what technology to use, how to develop resiliency, how to practice against and work against, and how do you work with customers in these situations. And so it's been a great consortium helping each other, thinking about best practices. And I would encourage, much like mutual aid programs and helping each other, consortiums like this really do make a big difference.
And the point you mentioned regarding consortiums and collaboration, I was just going to ask a question to Ian, since he's worked in many different scenarios. Do you see the possibility of creating these sort of a global mutual assistance? Because we saw it during the pandemic where you had some countries were sending doctors to other countries to help. Do you see the possibility where Japan and Australia could start sharing resources depending on the severity of the crisis, or maybe even Australia may send folks to the West to help and vice versa? You see some sort of a global consortium or global imperative for working together to tackle some of these extreme events going forward?
Well, I certainly think there's an opportunity, and it's a discussion that needs to be had in terms of how we can work with each other in terms of what our knowledge, our technology, our resources, our experiences, etc. The whole climate adaptation, I think, is not talked about enough. I know a lot of Australian utilities don't have climate adaptation plans. They're still relying on engineering design standards of 20, 30 years ago, yet the environment's changing around them. So they're not prepared. So how can we learn from other countries in that space? How do we use data and intelligence, the weather forecasting that some companies like IBM and others are doing across Japan and in Australia? How's that sort of turning out in reality? So look, I think conversations and discussions are all very positive, and we should try and assist where it makes sense. And I go back to that original event that I was talking about. There was an event just slightly before it in Brisbane where there was a large storm event and people were brought over from the border of New South Wales. These were trained linesmen. They were not allowed to work on the system under the regulations because they had different qualifications in New South Wales and processes. Before Yassi hit, we had our solicitor, legal officer, working with the regulators very quickly to ensure that everyone we brought up from Victoria and New South Wales, etc., could actually practice their trade, which was successful. So I think expanding that globally and the logistics of doing that, but it's not just resources, it's technology, it's regulations, it's all of those sorts of things, risk assessment, engineering, yes, we should do.
So you mentioned technology. Go ahead, Larry.
Well, if I could just add just a little bit, sometimes it's curiosity and a willingness to learn. I'll just mention that I had an opportunity early in my career to go to Japan and spend time with Hokuriku Electric Company. And when I thought leaving the United States that we had great reliability at 90 minutes per customer for SAIDI. That's our kind of average across the US. And I went to Japan and it was less than 10 minutes per customer. And you say to yourself, well, how do we get better? What's different here that we need to do? And so I think the curiosity, I took a group over following Fukushima to learn what could you think about hardening. What do you do in a substation? What do you do with transmission towers? What about the underground that you have? What needs to be hardened? And so organizations like JPEC, EPRI, CREPSI, we need to encourage that dialogue to take place. And I think all of us as industry leaders need to think about curiosity of how do we learn from others and bring what Ian has best or what Yoshiki has, to the United States or vice versa.
Yeah, I absolutely agree, Larry. It's having the courage to get out there and learn from others and don't sit back and think you know it all. Unfortunately, we are a strongly engineered-based industry that I've got to say, from a cultural perspective, has been used to doing things the same way for a long time, and therefore the inertia of that is hard to get over. And getting people to open their eyes up and experience other things is how that happens.
Let me tell the audience, if you have any questions, please go ahead and send. Yoshiki, did you have a comment? No. Okay. I want to move on to technology. Since you said technology, let's start with Yoshiki. Can you talk about one or two technology that J-Power is using to improve resilience in your system?
Okay, we are doing good trial for flood control for hydropower dams right now. It is very exciting. We have had fixed operation rule curves of dam water levels through rainy season, which are agreed with river authorities so far. The fixed rule curve must be kept even actual rainfall is very low. Rainfall depends on the route of respective trace of each typhoon route. Then we proposed the usage of satellite data for meteorology to predict precipitation by each typhoon and avoid meaningless storage without water storage without generation discharge. Step by step, and jointly with river authorities, we are realizing kilowatt-hour increase, keeping unchanged safety downstream. Now, our hydrologists are very earnest to analyze data of surface radars and those from satellites. This is a cutting-edge trial for our company, and we are now proceeding such argument with government. This is a new trial about resilience. One example.
I think that's a very good example. I know we're talking about the US and Japan and Australia, but I think that example has a lot of use in other parts of the world, especially in sub-Saharan Africa. We have a lot of floods. In parts of Asia, we have a lot of floods. So for those who are listening, even though these technologies are being discussed in the context of the US, Australia, and Japan, I think the applicability goes beyond these countries as well. Larry, let's go over to you. Tell us about one or two other technology PGE is using to deal with some of the severe events you've had to deal with over the years.
I think some of it I'm going to call out as a little bit of our basics. And I'm going to go with both automation, because if we can isolate again, that's all to the advantage. But that automation also gives you a lot of data. And we'll even go into the meter as well. And so your forecasting and the information associated with it, also your outage information, your analytics associated with understanding customers and their usage, and also outage, and getting much, much better at hardening based on that data instead of either gut reaction or using feeder information. You're getting down to neighborhoods, you're getting down to individuals. And so the detail is much, much greater. What we are also doing is, with wildfire, it's forced us into thinking about weather stations And having just a weather station at an airport 40 miles away doesn't cut it. You've got to get into localities and you need to be able to see that information. We're starting to use cameras as well. These are activated cameras based on smoke and fire. Again, doesn't trigger, doesn't send anything until it sees it. And then you get the alarm. You can't always ping, but it really gives you that advantage. Then also another technology is sensors to be able to detect that you've got corona, et cetera, on a feeder. That may be a broken strand of wire, it may be a cracked insulator, but you're able to detect where that is and go fix it before it fails. And again, could be leading to an ignition. So those sorts of technologies are available, and we're beginning to try them out and really look for assets that could be a possible failure to us and get ahead of it on the learning curve.
Ian, so there is one technology that fascinates me that I know a lot of people are talking about today, but we haven't seen a lot of applications in our industry, and that is the whole concept of digital twin. So tell us very quickly, what is it and why do you think digital twin is something that Larry and Yoshiki and other utilities should be looking at very seriously?
Right. Well, digital twin is a combination of things. It's a spatial digital twin in a 3D form. Time brings in the fourth dimension. All the IoT sensors that Larry talks about, etc., are bringing real time. Situational intelligence, the integration of your enterprise data in there, and your ability to build algorithms and to be able to analyze vegetation risk and conductor clearances and feeder loads and those sorts of things. So, in Ergon's case, and as you know, Ergon won the Edison Award in 2015 for this technology. When we were running Ergon, we had $104 million we were spending a year on vegetation. But I really couldn't see that the actual contractors owned the intelligence that was there, and we as a network did not. So we did create a digital spatial twin at that time of 160,000 kilometres of Ergon's network with object recognition, massive data processing speed, huge amount of intelligence, so that you could have a ubiquitous experience across the whole network, run analytics over the top. In one of the cyclones, Marcia, we had plane deployed, fixed wing, rapid capture, massive data capture very quickly. People talk about using drones, etc., but when you've got a cyclone, you typically want to do it at speed very quickly. And we were able to identify within 24 hours where all the lines were down, where would we put our HV generators into the system, and those sorts of things. As the energy transformation occurs and you get a lot of distributed energy resource across your grid, which has been built basically on the engineering standards, not on monitoring and control protocols, it gives you a foundation, if I can say, the Lego base plate to put all that data and other intelligence on. So you can see your business and you can run your business. It simply gets down to that. At the moment, I would say most utilities apply.
Ewan, can you give one example of one utility in Australia that you think is on the cutting edge? So if Larry and Yoshiki wants to travel to Australia to see digital twin in action, where should they go?
Well,
I'd like to visit Australia as soon as possible. May I have one comment about this?
We welcome you here, Yoshiki. We need to grow our tourism.
Where should they visit, Ian? Seriously, which utility do you see as one who is leading this effort on digital twin in Australia?
Look, in terms of future-focused models, we're dealing with one of them at the moment. It's not in terms of implementation, and that's TAS Networks, and that's a federated data model, potentially serving councils, government, federal governments, agriculture, etc. But the underlying value proposition is in the utility itself around line management, vegetation management. Companies that have got nearly 10 years of data is Ergon, in Queensland. It's probably got the largest data set in the world. Applications, I'd say they probably could do a lot more with. But yes, I'll take you to a few locations if you come over to Australia and show you what can be done. Others include Ausgrid and Endeavour.
Okay, so travel to Tasmania, Larry, if you want to learn more about digital twin. Yoshiki, did you have a quick comment?
Yes. Okay. So I agree with Lawrence. We should cooperate each other internationally. So each continent and island have differently indigenous disasters. But if we study stochastic models for extreme values by mass digital data, we may find some common knowledges. Everywhere, we have some mechanisms for extraordinary seismic motion, precipitation, wind, and temperatures. These problems are common in terms of science. So we should discuss more and more about science for anti-disasters utilizing mass data. So before we couldn't do that, but now you have to organize some discussion arena for this agenda.
I will do my best. We have about 6 minutes
Lawrence,
left.
just one additional point on that. Not just the data, but the democratization of data is critical. You know, I've seen towns where the utility's done a reasonably good job and we've got all the digital twin of the whole region and towns. But I can see the rail authority going straight through the middle and got trees into 33,000 volt power lines. So if I was a minister of a state sitting back saying, am I safe? Can I see the intelligence out there? Is it ubiquitous? Is it available to everyone? I'd have to say no. That's what digital twin can do, democratize data, bring everyone up to the same platform.
Yeah, it gets into the whole digital, the whole issue of vegetation management. I see lots of applications even for the US. So we got about 5 minutes left, and I'm going to call this the lightning round because I'm going to ask you some very quick questions and some quick answers. This one, I only need one recommendation in terms of, or one suggestion. What do you consider to be the biggest threat to power system resilience over the next 5 to 10 years? If you were to identify one thing that we should focus on as a risk over the next 5 to 10 years, what would it be? Let's start with Larry.
Next 5 years till 2030, I would say it is removal of carbon emitting generation and not putting fast enough renewable generation on board.
Okay.
So you've got a resource adequacy issue.
Resource adequacy issue. Okay. Yoshiki, what is the one thing we should focus on that you think would be a big risk factor for the next 5 to 10 years?
Okay, I would say another big earthquake along Asia Pacific region is still including Japan. This is my concern. And let me put one more.
Okay.
Fuel supply disruption by geopolitical reasons. This is another thing.
That is a whole topic for tomorrow. We're going to be discussing supply chain.
Yes.
Ian, what will you say is the big risk we should be thinking about towards power system resilience over the next 5 to 10 years?
So I'll put in an Australian context. I think a philosophical approach to markets, that markets solve all problems. We designed the networks originally to deliver a service, and they were engineered with all the resources available to them and all the technology. So they picked the best solutions at the time. There's no reason why that should not apply today. And because it hasn't applied today and people believe the market will solve all problems, we are now wasting and spilling renewables. We have constraints across the grid. We have low load issues. We have security issues. I do think it needs a bit more engineering and less market.
More engineering, less markets. Okay, as an engineer who believes in markets, I'm going to fit in both worlds.
And I'm not an engineer, so I can stand on the outside and say I'm unbiased.
I'm going to share, Lawrence, a quick philosophy that I stay with, that technology and commercial have to go hand in hand. If technology gets out ahead of commercial, you can't afford it. If commercial gets out ahead of technology, it won't work.
So Larry, then, since you brought that up, let me ask you quickly then, what gives you confidence that your company, PGE, or the industry in general, is ready to achieve resilience over the next 5 to 10 years? What gives you confidence?
Because we're going to engage with customers. And they are signaling to us loud and clear that we need to work to develop resiliency with them. We need to engage with them. They need to become a part of it. We talk about the digital twin. To me, that's a virtual power plant. That's how we interface, and their devices are plug and play. How we advantage that to keep it affordable, keep it safe, keep it reliable, and engage with them to decarbonize our entire system.
Yoshiki, what gives you confidence that J-Power is going to be successful with resilience over the next 5 to 10 years?
One thing is our enthusiasm. Even we are a member of private sector, but I'm not confident about successful resilience adaptation, because in general, private sector companies have a limitation of capabilities financially to protect continuous power supply from natural disasters upon their balance sheets, financial balance sheets. Some ideas about public-private sector demarcation rule from corporate financial views, like Basel Accord about financial risks. So public sector and private sector should cooperate and should be demarcated. It's very simple.
Well, my last question to wrap this conversation, it has been fascinating, lots of new ideas, lots of good conversation, but I have to ask the question I've asked everyone since we started this series. So based on your expertise as a professional, but also as a citizen of the world, what would you consider as success coming out of COP26? If you were to talk about success after COP26, what one thing will define success for you? Ian, you go first.
Well, I think it's it's almost the timing and the event itself. So Australia's been preparing itself, and if you look at Australia's history, we've lost 3 prime ministers because of these debates, and now current prime minister is going there with certainly some agreements on targets, etc. So politically, there's a little bit more alignment than there was a little while ago, and a lot more focus on technology, a multidisciplined approach, not just a renewable target, which they had before, very one-dimensional. It is based on technology, good policy, also sequestration, which Australia's dry, etc. I think the event itself has already created some success for us.
Good. Yoshiki, what will you define as success after COP26?
Okay, the interaction between energy policy and climate change are based on scientific knowledge about CO2 as well as methane, geographical tactics, looking at economic advantage among continents or regions, through rule makings behind ethical belief of humanity. Anyway, establishment of a agreed common goal and respects for different transition process by country simultaneously would be the key, I hope.
Well, Larry, you get the last word because you started us off. So you tell us, what would you consider to be success after COP26?
I think, first of all, it's awareness of the urgency, that these events are happening across the globe, and that we all need to take it seriously. That then leads to more people getting involved in our industry. We have from technicians all the way through universities. We need help to think about resiliency. And if I were to leave with one thought, if you have an opportunity to watch the old John F. Kennedy University of Rice University speech on going to the moon, and the challenge. We do it not because it's easy, but because it's hard. And if you think about building what he talked about, a rocket ship that was over 300 feet out of metal alloys that haven't been invented, control systems that haven't been designed, and doing it at speeds that have never been achieved, that's what we're faced with. But our mission is to save the planet. And I really hope that that comes across loud and clear.
Well, no one better not to stop on than saving the planet, based on the same analogy of John F. Kennedy, taking the man to the moon. Let's see if we can make this climate shot solution solving the world's problems. I appreciate you guys taking your time. Ian, early morning for you. Yoshiki, the same thing. And Larry, time for you to perhaps go and have dinner. So thank you so much. Thanks to the audience. And I will now turn it over to Vanessa, who will wrap us up. Vanessa.
Thank you very much.
Thank you so much to Larry, Yoshiki, and Ian for joining us today and sharing their insights with us. And thank you to everyone for joining the conversation. We will be sending out a recording to all attendees, which we will also be sharing on our YouTube channel, where you can find recordings from other past virtual conversations and webinars. We encourage you to register for other sessions in our COP26 webinar series by visiting tinyurl.com/EEI COP26. The Destination 2050 dialogues will continue this week with sessions focusing on supply chain risk and how to become nature-inspired leaders and communicators as we address the challenge of climate change. To continue engaging with EEI international programs, please follow us on Twitter or visit our website. Thank you so much and have a wonderful rest of your day.
Thank you.
Thank you very much.
Thank you.
Bye.
Bye-bye. Goodbye.
You all take care.
Thanks, bye.